to start the simultaneous differential equations. So these kind of differential equations is of the form dx by p equal to dy by q equal to dz by r. So this is the format for that, where p, q, r, these are the functions of x, y, z. For example, p can be taken as x plus z, or q can be taken as x into x plus y minus az, where a is a constant. So p, q, r, these are the functions of x, y, z, right? We can get the solutions or integral curves from this equation as first solution to be as u1 x, y, z equal to c1, right? And u2 x, y, z equal to c2. These are the solutions or the integral curves we get from this kind of differential equation, right? Where this c1 and c2 are the arbitrary constants. Okay, let's move on to one example. Find the integral curves of this equation, where this is your p, this is your q, and this is your r. So these are in the forms of x, y, z. Also, there is a constant a. So let's get the solutions for this differential equation. We are having this differential equation. Now these three are equal. If we get the ratio as, let's focus on the denominators first. If I add this denominator to this denominator, what I get? I get x plus y whole square. So on adding these two denominators, we get x plus y whole square, yes. And in the third denominator, I'm having z into x plus y. We have to add or subtract or make the ratio as, so that we can cancel something from this ratio to the another one, right? Which will make our solution easier to get. So let's get the ratio by adding these two. So each ratio, that is dx plus dy divided by the denominator of the first ratio, adding this to the denominator of the second ratio, and is equal to the third ratio, that is dz divided by z into x plus y. So from here we get dx plus dy in the numerator as it is, and in the denominator these two cancelled out, and we have x plus y whole square, that is equal to dz divided by z into x plus y. So cancelling one x plus y from both the sides, we get dx plus dy divided by x plus y equals to dz divided by z. And then we have to take the integration on both the sides. So on integration we get, if I integrate this with respect to x plus y, because I'm having x plus y with this d, so we get log of x plus y, and is equal to integrating this with respect to z, we get log of z, plus the constant I'm taking log of c1. So this is log of x plus y equals to log of zc1. That implies x plus y is equal to zc1, and from here we get the value of c1 in terms of x, y, z. Please mark this as 1. So this is your first solution or the first integral curve. Similarly, we can get the another one from this differential equation, yes. If this is the first way to get the solution, we can also have the another way, where if I multiply this denominator with x, and this denominator with y, and this denominator with a, what I get? Yes, let's have a look. We get xy into x plus y plus azx from here, and then if I subtract this one, that is xy x plus y minus azy, then again subtracting this one, that is azx plus y, which is azx plus azy. Now this azx is cancelled out with this azx because there is a negative sign. And also, if I manage these two, we get positive AZY, which is cancelled out with again this negative AZY. And then this XY into X plus Y is cancelled out with this. So we are getting 0 here, right? We are getting 0. So let's use this way to get the ratio. So each ratio equals to multiplying this first ratio with X. So this is X dx divided by xy into X plus Y plus azx, and then subtracting this ratio, but first this is multiplied with y. Let's multiply this ratio with y and subtract minus xy into X plus Y plus azy. Then multiplying this ratio with z minus multiplying this ratio with a and subtracting. So this is a dz. So in the denominator also minus azx minus azy. So this is what we are getting in the denominator. So cancelling this, also this, and also this is cancelled out. So therefore we are getting x dx minus x dy minus a dz, because the denominator is 0. And if you equate this ratio to any of these ratio, if there is anything on the right hand side, so you will be getting then x dx minus x dy minus a dz to be equal to 0. So on integrating this equals to, if I integrate 0 with any variable, I will be getting this to be as a constant. Let me write this as C2. So on integrating the left hand side, we get x squared divided by 2 minus y squared divided by 2 minus az equals to C2. Or we can get x squared minus y squared minus 2az equal to twice of C2. That is again a constant, C2 dash. So this is your another solution or the integral curve for the given differential equation, marking this as 2. So from 1 and 2 we get together the solutions or the integral curves of the given equation. Alright, thank you. Stay blessed.